today we're going to double dip and start two of the multitude of quadrilaterals we're going to talk about in this chapter. And in fact, chapter 6 is an emphasis on just plain old quadrilaterals. Okay. And you can see, or hopefully you're seeing, where eventually we'll have so many quadrilaterals that we're going to need some type of hierarchy, which is why I introduced the hierarchy earlier. We're going to start with a parallelogram, and a parallelogram is a good place to start because it is one of the most general quadrilaterals that we'll deal with. I'm going to besiege you with a bunch of information about a parallelogram because there's a lot of things that are true about a parallelogram, and then as we move through the other shapes, the other one we're going to do today. The other thing we're going to do today is talk about rectangles. So then, with rectangles, you'll see that some of the things that are true about parallel. Sorry, that was my fault. I'll try not to do that. Oh, you're too quick. All right. So here we go. Turn on clicker. Clicker not working. Come up to board. Okay, there's a parallelogram. You got to look carefully, but I got a bunch of arrowheads on that picture. And I seem to have forgotten, but Ryan's going to help me out. What do those arrowheads mean?
It means the two opposite lines are parallel.
Yeah, because it's called a parallelogram, so we're probably going to have some things in there that are parallel. Well done, Ryan. So Riley, what is a parallelogram? There's one right there. It's yellow. It's not a good way to start a definition. Start over.
A parallelogram.
That's a good way to start a definition, defining the term which you're trying to define. Is a
It is a quadrilateral.
Oh, that's a really good start. Okay, so we've determined so far that a parallelogram has four sides.
Yes. And it has two sets of parallel lines.
And where are those parallel lines located in relationship to each other?
On opposite sides of the...
On opposite sides. Very good.
Yeah.
So you want to say that all again? See if you can do this entire definition without an
Or like, a parallelogram.
Hold on. I'm gambling right now. What?
You just do five because Riley's not going to mess up.
All right, here we go. Definition without an
Or like a
Or a like? We'll
Yeah,
throw
or
that
like.
in too?
Yeah. Also, if I say like.
Somebody's getting big for her britches. All right, go ahead.
I know about that.
Here we go.
A parallelogram is a quadrilateral that has two sets of parallel lines that are on opposite sides of each other.
Push-ups. Let's give it up. Well done, Riley. Good. So we're going to start with the definition, which, let's see how mine is. It's pretty close, yeah. Okay, good. Well done. That's our definition. And each of these quadrilaterals is going to have a definition, but then we start talking about all the properties that are also true about that. Okay, so you think about something like a dog, and a dog, if you were to define a term dog, you would have a definition of what a dog is. But then a dog has all kinds of other things that aren't necessarily mentioned in the definition. Okay, they wag their tails, they can be taught to play fetch. They can do all kinds of other things that aren't part of the definition. The same is true with quadrilaterals, parallelograms. The problem with parallelograms is it has the most properties. And we got to get this big one out of the way first because it makes all the other ones easier. Okay? So, before I click, what else is true about that yellow thing? Logan?
It has an It has an interior angle sum of 360 degrees.
Awesome. Is that true of parallelograms or quadrilaterals or both?
Both.
Do we need to include it on the parallelogram definition even though it's true for all quadrilaterals?
Yeah. No, because it already says.
I don't care one way or another. Yes or no?
Yes.
It is a property. Okay, good. Angles add up to 360. What else you got? Go.
No right angles.
Huh. Could it have right angles?
Yes.
If it had right angles, would it still be a parallelogram?
No.
Yes,
Wait.
yes, it needs the squares.
Yes.
Oh, we are gonna have some fun with this one. All right, we'll come back to that in a second. What else? Go, Donna. Go ahead. Sides or angles? Yeah. 2 of the angles are acute and 2 of the angles are obtuse. Does it have to be that? In this one, yeah, but I'm talking about parallelograms in general. There is one small exception to what you said, which we'll talk about later, which is what the can of worms is. Zoe, what do you got? Coward.
I was gonna say it's a quadrilateral.
It's not a false statement. Leah?
It's a closed shape that's not.
Because it's quadrilateral.
Wait, what are we arguing about?
We're not arguing about anything. I just want to know what else is true about this thing.
Oh, okay. It's like.
Zoe? It is yellow. Very good. Thank you, Captain Obvious. Are all parallelograms yellow? No. Yes? Oh, it does have 4 angles. What about those angles? Oh, you're so close. All 4 of those angles are congruent? Danny?
2 angles are congruent and the other 2 are congruent to each other.
Good. Which angles?
The opposite ones
Are we done?
each other.
Good. Okay. Back to you, Danny.
The ones opposite of each other.
Beautiful. Okay, good. I like that. Opposite angles are congruent. What else? All right. Oh, Logan.
Well, I guess this kind of goes with just quadrilaterals, but they are closed line segments.
It's quadrilateral, which is also a parallelogram, which is also a polygon. So yeah. Okay. Opposite sides are congruent. Right? If you go back to the picture, you can see the top side is equal to the bottom side, the left side is equal to the right side. Okay. Opposite angles are congruent. Thank you, Danny. Let's go back to the picture and label these angles for discussion purposes. Okay, so Danny, you said that angles 1 and 2 are equal to each other,
Yep.
and angles 3 and 4 are equal to each other.
Yep.
Okay? Now, clarification, Lana, you were correct that there are 2 angles that are obtuse and 2 angles that are acute, except on one particular case, and that's when they're 90 degrees, which we'll get to later on. But most of the time, that is a true statement. Okay, so we've got that already, that 1 and 2 are congruent and 3 and 4 are congruent. What's the relationship between 1 and 4? Danny?
They're supplementary.
Why? You are correct, by the way. Why?
Because they're on the same line.
Why? I can give you a hint. The top sides are parallel to each other. The left side is a transversal. So angles 1 and 4 are supplementary because they are
Same side and interior.
beautiful. Okay? Let's build on that. What's the relationship between 1 and 3? You got to look at it like this.
Same side interior.
Go ahead and look at it like that. Okay, what's the relationship between 1 and 3?
They're same side interior.
Excellent. This one's going to be challenging. 2 and 3, you have to look at like this. Because we're going around in a circle. Let's just get dizzy. Excellent. What's the relationship there?
Same
God, I
side
wish we had this
interior.
on video. I'm sorry, what?
Same side interior.
Excellent. I'm afraid I'm going to throw my back out, so I'll just ask you, what's the relationship between 2 and 4?
Same side interior.
Excellent. So, if you wanted to make a general statement then of those 4 conditions you just listed, okay, that 4 and 1 are supplementary, 1 and 3 are supplementary, 3 and 2 are supplementary, 2 and 4 are supplementary, how would you generalize that? You understand what I'm asking? Like, not every parallelogram is going to have angles 3 and 4 labeled this way, so you can't say, well, in any parallelogram, angle 3 is equal to angle 4. You said opposite angles are congruent to each other. So how do you describe to some layman that walks in the door without these numbers here that angle 1 and 4 are supplementary, angle 1 and 3 and 3 and 2 and 2 and 4? Kind of on them? That's German for no idea. Eva?
Would you say, angles that are on the same line or something like that?
It's not horrible. I mean, it works for me. If they're not opposite, they're what? No, location-wise.
Adjacent.
Adjacent, I like that. Who said that? Me, doesn't Robbie, was that you?
Yeah.
Oh, thank you. Okay, so, blah, 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 blah. Oh, yeah, there's a picture. Notice the tick marks for the angles. The one has just 1 mark because they're equal to each other. The other one has 2. The same thing is true with the sides. 1 tick mark showing the opposite, 2 tick marks showing the other pair of opposite. It does not imply that all 4 of them are equal. Okay, you don't necessarily need that picture, so I'm just going to keep going. What else do we got? Consecutive. Okay, I use consecutive. You could use adjacent. Maybe we've used adjacent before. I don't know if we've used consecutive before. But the adjacent angles are supplementary based on what Danny told us. Angles next to each other add up to 180. Angles across from each other are equal to each other. All 4 angles added together give you 360. Ooh, now we throw in the word diagonal. We've talked about this before, but I'll refresh your memory. Remember, the diagonals are the segments that go across the figure. Technically speaking, a diagonal is a segment that connects non-adjacent vertices of a polygon. But we don't care about that. It's just the sides that go across. I drew a bunch of diagonals on Tuesday when we were talking about the polygons being broken into triangles. In a parallelogram, they chop each other in half. Fancy term for that is obviously bisecting.
Are we gonna do like? Wait, are we gonna get quiz back today? And then also, are we gonna have so the quiz on this? Is it only gonna be these 2 lessons, or do we have like?
We got more stuff coming up.
Yay.
All right, we good? All right. In that case, I have a question for you. Brandon, what's the relationship between that angle and that angle?
They are opposite side exterior.
You're close.
They both equal 90. No. Well, they'll have the same measure
Yeah. Why?
because they're because the opposite angles are, if they have the same angle, the opposite angles, then you have the diagonal there, so it splits it in half evenly.
No, these 2 angles are not equal. Your answer is correct, though. That angle is equal to that angle.
Yeah.
But why? Anybody? Leah? No, you're just putting your finger in the air. Does that help you think?
Yeah.
Okay, I understand. Rad Rob. No? Anybody else? Those are alternate. Oh, sorry.
Is it because they're like opposite exterior?
Alternate interior.
Yeah.
Yeah, which also makes these angles equal to each other.
Oh.
which makes this angle equal to this angle, which makes this angle equal to this angle. They are not bisected, however. Those sides are not chopping that parallelogram angle in half. They're broken into a whole bunch of different triangles. Okay, so there's a lot that's going on in a parallelogram that we won't explicitly talk about, but is still a property of that parallelogram. Okay, so any questions on any of the properties? Now, this is going to be a little confusing. What's going to get worse is we're going to start talking about other figures in a little bit, and they're going to have their own properties. And some things that apply to some shapes are not going to apply to others. Some things that apply to others might not apply to some shapes. Okay? It sounds very confusing, and it is. And that's why we're going to use a hierarchy to keep track of that. Okay? So, solve that problem, please. Lucy, what's X? Oh boy. Leah?
I haven't got it either.
Michael? 27.
That's what I got.
Okay, we're gonna go with it. I got a confirmation. How'd you get that?
Well, opposites are equal to each other.
Is that the answer to the problem?
Yes. Oh no.
No. Okay, now, here's where things get a little bit nitpicky. What are the units on that answer, Michael? No units. Just the value of X. So notice in this problem I'm asking you to solve for angle D. He got X being 27, but I need to solve for angle D. So, Michael, how do I find the measure of that angle? Because I don't have a measure for it. Would you like some help? Lily?
You plug in 27 for X in A.
In A? Okay, so 27 times 4 is 108. Minus 9 is 99. Okay?
And you do 180 minus 99.
Well done. 180 minus 99 is 81. Is that right? 81? Yeah. 81. Now all of a sudden the degree symbol pops up because we're talking about the degrees in an angle. Very good. Any problems? Excellent. Now some fun. We're going to take a shape and we're going to put it on a coordinate plane. And then, once it's on the coordinate plane, we want to answer this one particular question. Okay? So if you will recall, a couple classes ago, I proposed an idea that Michael is a dog. And you shut me down because he didn't have all the properties necessary to be a dog. So, if I'm hypothesizing that RSTV is a parallelogram, what must be true about it? Okay, so hold on, let's do this first. 1, 1, 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, 7, 8. 8. And 1, 2, 3, 4, 5, 6. 1, 2, 3. If I just put 4 points on a board, you could connect them in a couple different ways. When you have a triangle, that's not an issue. If I give you 3 points on the screen, there's only one way to connect the 3 points and you make a triangle. Quadrilaterals are different. Okay, so the way that we're going to handle that is, notice how the parallelogram is named. RSTV, that's the order that you go in. RSTV, and then back to R. Okay, so the question I have for you is that a parallelogram? Now, you might say, yes. Why? Because it looks like one. That ain't going to cut it. If it is,
Sorry.
don't be sorry, that's okay.
No.
If it is, what must be true about it, Ava?
Like the lines, the opposite have to be parallel to each other.
Good. Method number 1. Parallel. How else could I show that that's a parallelogram, Zoe? Slopes. 3. How else could I show that that's a parallelogram? Juliana? Duh. Distance. Okay. 4. You're not going to get it, but I'll put it up there anyways. What else must be true if that is a parallelogram? By the way, we don't have the math right now to calculate how big those angles are. I mean, we do, but it's way too much work. So we're not going to deal with like opposite angles being congruent or adjacent angles being supplementary. There's another method to show that that's a parallelogram. Nope. I'll just tell you, and then we'll talk about it in a second. It's the diagonals. I'll come back to that in a minute. To be honest, I love working with the diagonals of polygons because I think it's an easy way to do it. Most people do not. Okay, so let's suppose that Leah wants to use method number 1. What are you going to do? Good. And what do you need to find in order to show that they're parallel? How do I know if RS is parallel to Viper Turtle? Say it loud. The slope of the lines are the same. So I actually kind of let you go, but notice that answers 1 and 2 are the same thing. Okay. In case you didn't hear Leah, she said, if I want to see that if RS is parallel to VT, I need to calculate their slopes, and if their slopes are the same, we're good to go. All right, we're not going to do the math. I'm going to talk about the method. Okay, we good so far? Liam, you'd like to use method number 3, which is using distances. What would you do?
The distance from
For?
T and V and S9.
Right, and?
See if they are equal to each other.
You have a program that calculates distance. Plug and chug, calculate the distances. If that's a parallelogram, then RS is going to be equal to TV, and ST is going to be equal to RV. By the way, you got to check both pairs. So getting back to Leah's approach, you got to check that, and you got to check that. Liam's approach, you got to check that, you got to check that. All right, then I'll do number 4. If I was doing number 4, if I was solving this problem, what I would do is I would check to see if the diagonals bisect each other. How would I do that? Liam.
Take the midpoint of R and T and S and V.
Beautiful. If they bisect each other, then this point right there has to be the same midpoint for both segments. So as Liam said, I would calculate the midpoint of RT, I would calculate the midpoint of SV, and see if in fact they are the same point. If they're not the same point, then it doesn't work. If the distances don't match up, it's not a parallelogram. If the slopes opposite sides are not equal, it's not a parallelogram. Don't assume that every time I give you a problem like that, it's going to work out all peachy keen. Okay? Which method do you use? Use whichever one you want. Most people, I will tell you from experience, will go with the distance approach because you get a program that does it for you. Okay? Question over here? Okay? Any questions from you guys? All right, again, we're not going to do the work because I'm assuming you can all plug numbers into a calculator. Yeah, that one I talked about already. Okay, great. Let's get through this because I have other things to do. Real quick, because this is a parallelogram, because we know that's the midpoint, then this side has to be equal to that side has to be equal to that side. And all these angle measures we talked about already using the alternate interior and that kind of stuff. Okay. And then lastly, same idea. Oh, look, a system. 5y is equal to 7x minus 5. Is that solvable? No. How big is 5y equal to? Other than 7x minus 5. Lily.
Wait, I don't know. I thought I did.
Carly.
Would it be? Wait. Never mind.
Is it 110?
Nope. Nope. 65. Why?
Because I did 45 to 70 and I subtracted that from 80.
Good. Now all of a sudden you can solve for y. Now all of a sudden you can solve for x. You're done. Okay. This by itself is not a solvable situation. Okay. Again, remember the rules. 2 variables, 2 equations. Oh, look, I have 2 equations. Life is great. Let's move on to rectangles. What? What? How's this? Doesn't work when she doesn't look. Okay, that was the bad one. Now that we got the parallelogram under our belt, the rest of these are simple. For the most part. So, for instance, we're going to talk about a rectangle. Here's a rectangle. Oh no, I didn't give you a rectangle. I'm just giving you stuff. What the heck? Getting soft in my old age. Well, now that's up there, I can't really take it back. A rectangle is a parallelogram with 4 right angles. Golden retriever and dog. Are all parallelograms rectangles? No. Are all rectangles parallelograms? Yes. Okay. So, aside from the dog and parallelogram, come on, read. Dog and golden retriever example, we can also talk about the properties. Okay. A golden retriever is a dog. Does it have all the properties of a dog? Yes. Okay. Any problems there? So we're going to make our life simple. A rectangle is a parallelogram. So everything we did already about parallelograms is also true about the rectangle. We don't need to do it again. The only exception is, and this is what I was talking to you before, is that now all of a sudden we have 4 right angles. Other than that, there's no difference. Except for a couple things. 4 right angles. That's the same. Still more to stop now. Opposite angles are congruent. Where's the one I was looking for? Oh, no, we got that. Wait a second, what did I miss? There is one special property about rectangles. Opposite angles are congruent. That's all true. I said, okay, yeah. Huh. I must have forgotten it. So you tell me, if that's a rectangle, it has to do with the diagonals. What do you notice about the diagonals? Triangles. Yes, that's true. There are triangles up there. Okay, good, Riley. Logan? Yes. So the other big difference between, oh, it says right there. I'm an idiot. Sorry, kids. I'm off my A game today. It's been a stressful morning. I didn't want to talk about it. I'm okay, yeah. It's just that, I had stuff to do first period, and then I ended up having to take somebody home because they were sick, and then they couldn't drive, and it's just... I don't talk about people's personal lives. Sorry.
Wait, but like, you drove. Were you the teacher or was it another? Or was
A
it-
teacher. A teacher got sick this morning and they couldn't drive home. So I had to drive them all the way home and get back, so I get my work done first period. And I forgot I'm recording this and now it's like. Let's move on, kids, okay? So parallelogram has all those different properties. The two different things that show up on a rectangle is that it has 90-degree corners and the diagonals bisect each other. No, sorry, and the diagonals are equal to each other. Okay? They already bisect each other because it's parallelogram. Alex?
Can you go back one slide?
Sure.
It's curious.
Waiting. You good? Okay, beautiful. Okay, so, there we go. That's it. This process that we just went through is going to repeat with all the other quadrilaterals. We got to talk about rhombus. We got to talk about square. We got to talk about, well, do you know any other quadrilaterals? We got a trapezoid.
Hexagon.
No. What?
Kite.
A kite. Yes. You missed one.
Square. Rectangle.
We got a rectangle.
Square.
Square. Isosceles trapezoid is also going to be. Okay. Diamond. Diamond is a rhombus. Yeah, we'll get to that later. Okay. Blah 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 blah. Yeah. Example. Great. Okay. Yeah. Great. Yeah. Fun. Great. Boom. Done. Okay. So you have two things to work on. One first, which you're not going to be happy, is due at the end of the period.
Oh, no.
Shut it. This is what you're going to do. You're going to create your own hierarchy. What does the sign up there say? No whining.
I have a question.
You're going to create your own hierarchy on any topic you want, except dogs, living things. By the way, did we talk about the whole fact that a rock is not a living thing?
I think so.
Which one did you knuckleheads ask me about? I forget who it was. You're not going to admit to it anyways, but somebody on the living thing said, do you use all these words? And I just pointed at rock. Okay, dogs, desserts, living things, and Winter Olympics. Any other topic, hierarchy. And you have to have at least 12 terms.
Do we have to make a word bank?
Yes. Okay, any questions? While you're working on that, I will unlock the day 2 homework. When you get that hierarchy done and submitted, then you can start on the day 2 homework. Okay? Beautiful. Hold on.